Good morning, everyone from the North Pole. I'm in Blair, Nebraska. As you can see, I'm bundled up. I believe the wind chill outside right now is negative 20 something. Even though it's heated in here, it's still cold, so I'm bundled up. So today I'm going to walk you through the steps of cutting out a sign. One of the things that I offer is CNC plasma cutting, and I do a lot of signs, personal requests, part cutting. So today I'm just going to show you a sign request that's come in. So here's the drawing. I've already done that. I'm not going to go through that in this video of how to draw it. I mean, that'd be a video all on its own. But I use Inkscape for drawing. I know how to use it. I can get it to do what I want it to do. And so that's what I have stuck with. I have a Shop Saber Sidekick 8. I can fit a 4x8 sheet of steel on there. That is the working envelope. And my plasma cutter is a Hypertherm PowerMax 65. That baby will cut up to 3/4 of an inch of steel with a cutting in from the side, or will pierce 5/8 of an inch. So there's been very few times where I've needed to cut anything bigger than that. So let's go ahead and get started. I need to start up the air system. This is a refrigerator for the air compressor, where the hot air will come out of the line. And I've done this cool little idea. I saw it on the internet quite some time ago. But anyway, these are copper lines where the air will come through. It'll cool down the air before it even gets to the refrigerator. And you'd be surprised at how much water will come out of these valves after it's been running even for a half an hour. Really knocks down the moisture. With plasma, you need to have dry air. So go through the coils into the refrigerator and then out into the system. It will come into this, which is a motor guard filter. It looks like a roll of toilet paper in there. So then from the motor guard, then it will go to the plasma. Okay, so now I'm going to walk you through the steps of how to take this drawing and make it into a part. So I have my sign here. The overall size is going to be 30 inches wide by roughly 17 3/4 high, and I can see that from my parameters up here. Okay, so this is how I want it. I have done everything I need to do with it. So saved, and it's saved as Montana Silhouette. So my drawing is done. So now I'm going to take that drawing and come into my processor. This is what writes all of the code to tell the machine what to do. So I'm going to get my new part and come in there, Montana Silhouette. It's going to open it, say okay, and so there it is. So now what I do is I come down here, select the kind of contour. Outside means it's going to cut to the outside, the keep part, as noted right here. I'm going to input exactly what kind of metal I'm going to put into it. So I'm going to cut it out of 1/8 inch steel. So I'm going to come here and it's going to say 45 amp fine cut 10 gauge mild steel. Yeah, I know 10 gauge is a little bit thicker than the 11 gauge, which is 1/8 inch, but I've always used this because it came pre-programmed. So select that. And then I'm going to go with my lead-ins, lead-outs. I like to do arcs. Lead-in, I have read that a good rule of thumb is twice the thickness of the material. So 1/8 times 2 is 1/4. So it's going to give me an arc in, lead-out, and I'll show you what those look like. So if you look right here, there it is, the lead-out comes in an arc. You can do those in different ways too. Not really important right now. So basically it is showing me how the machine is going to cut it. I'll go through and review everything to be sure that there aren't any little outliers in here, something that shouldn't be there. I've already looked through this, so I'm pretty happy with it. So then I'll post-process it. It's going to give me the name, and I'm going to hit save. It already exists, so I'm going to hit yes. And so now it is written lines of code. So now I'm going to go to the program for my machine to cut it. Okay, so the machine is on. Now, before I can do any actual cutting, I need to home the machine. It's basically going to square itself off. So it'll lift the torch up. That's doing a Z-axis home. Now it's coming towards me, which is going to be a Y-axis home. And then the trolley up there will go left, right, and that will be my X-axis home. So basically it's just the machine going through a self-calibration process. So now I can take over control of the machine. So I'm gonna take it all the way up on the sheet here. And as I said earlier, it's about 30 inches wide, 17 tall. So what I'm gonna do is walk it all the way up to that top right-hand corner, because this is just a rough sheet that is just kind of left over. Normally I'd start in bottom left, but since I want to get the most use out of the sheet, that's how I'm going to do it. So I'm putting it all the way up there to that top corner. I'm going to zero it. So that is now my home location. I'm going to walk it down, because I said 17 3/4 high. So I am going to go right. Okay. 17 3/4. So now I'm going to rehome that. So now I know that I have 17 3/4 inches from where the torch is now all the way up. So now I need to walk it over here. And that's going to take me, as you can see, to the 30 inches that I need for the width. So that's my new home spot. Now I do know that I'm not on the sheet, but I'm going to check that later just to be sure. Okay, so now I'm going to open up the Montana Silhouette. Open. And it's going to give me my screen right there. So as you can see, this is where my torch is at right now. So if you can visualize that. So now I'm going to basically walk that torch around the outside border just to be sure that I'm going to land on material. So I'm going to come all the way up here. So as you can see, that little red dot, that means that's where my torch is at. So I'm right there. So I'm going to walk up. So as you can see, that's the top left corner of the silhouette. And I'm going to go down, and then I'm going to zoom in here, and I'm landing on the sheet as I thought I would have. But anyway, I'm basically going to trace the edge and follow it around. So as you can see, tracking. Top right corner. Good, but as you can see, it tapers down. Oops, gotta lift that up just a little bit. Oh, crashed. That will happen. It's got a crash sensor in it. If it rubs on the sheet, sometimes there are bows in it, bumps. It happens. It's okay. It's protective countermeasure of the machine. So there's my bottom right corner. So I'm still on the sheet. Come over to roughly there, still on the sheet, continue my tracing, obviously going to be on the sheet. Okay, almost done. Okay, so I am confident that all of our cutting area is on the sheet. As I told you before, where the XY, the home spot, was currently at, which would be right there, was off the sheet. That really doesn't matter because there's obviously nothing going to be cut here anyway. So now we are ready to do the cutting. Spoke a little too soon. No, we're not ready to do the cutting. I need to come check my consumables. Going to take off the ohmic sensor wire here. Going to unscrew the retaining cap. Be sure that my swirl ring is good. And I'm going to check the consumables in here. So this is the electrode. We want to be sure that that is not burned down too far. A 1/16 of an inch is supposed to be the normal amount of wear, which I'd say we still got life in that. It's the shield. That's what the plasma arc will run through. It helps maintain its shape. And then this is usually where I do the most looking. This is the shield. I'm going to go ahead and clean that off because the ohmic sensor is going to constantly be running a voltage from here through that wire to this tip, and that is basically going to do constant sensing to be sure that my cut height remains the same. So I'm going to clean this up a little bit just to be sure it's a good contact, and then I'm going to reassemble it, and then I'll be ready for cutting. I got a regular stainless steel wire brush, brushed off the top, it's good and clean. Brushed off the top of the shield. It gives me a chance to take a look at it. It looks like it's still got life in it. Check the inside too. And the electrode, which is also good. So now I'm going to reassemble everything, and then we're going to start cutting. So shield goes in first. Be sure it's down, because you want to have the cone edge facing downward. The electrode, the hafnium point goes down. It looks just like that. And then this just slides right over and threads back in. Go all the way to snug, and then back off about a quarter turn. Doesn't need to be that tight. Reapply, hook up your ohmic sensor wire. Let's go ahead and power up the plasma cutter. Okay, there's a code on there because I don't have the air hooked up just yet, but I like to keep it on this setting right here. It's the perforated setting, so that way if it ever breaks arc for a second, the arc will still remain. I'm setting to 45 amps because that is the type of consumables I have in there. 45 amp rated. If you go too high, it's going to ruin them real quick. Okay, hooking up the air. So now the air, like I said, going through my coils, into the air dryer, into the filter, and then over to the plasma. And that code should have gone away because now we have air, but let's check just to be sure. And we do. That orange light is gone. Okay, we are so close to cutting. Back to my home, okay, which is there. So I'm one click away from starting this. But first we need PPE. So I'm going to put in my earplugs because it's going to be loud. I'm going to be sure that I have my plasma glasses. So that way I can watch it because it's just like welding. It's very bright, not as intense, but you should also not stare at it. And then I'm going to turn on my exhaust fan because, well, I just don't want to huff burning metal. So everything's ready to go. Fan is running, machine homed, program is set, PPE on. So let's go ahead and check the settings on the computer one last time. 10 gauge mild steel, that's correct. It's correct. I'm gonna click go, and it's gonna start going over to the first position. It's gonna come down, do a touch off, set the pierce height. All right, the cut is complete, so I'm gonna lift my torch up, back it out of the way. Since my magnetic wand broke, I'll just go ahead and use a bigger magnet. Pull it on out. Now set it out, dry it off, and then on the back side you'll have dross, which is just little bits of molten metal. I'll go ahead and clean all of that up with a wire brush and then bend out that tab. Here's the dross that I was speaking of, this little tiny bits of metal. Some of them it comes off pretty easy. You can just kind of knock it off with a finger or a little tiny scraper, but I'll use a wire wheel and a 4-inch grinder and it will come off. First bit I'm going to do is take off the dross with a wire wheel, 4-inch grinder, and then when I get done removing all the dross, the wire wheel, I'll take a flap disc and smooth down any of the other spots. Okay, cleaning is done, so no dross. Nice smooth to the touch everywhere. Looks good. And again, that's the back. You might have just a little top side dross sometimes that'll be up here, but then again, this side will just need to take the wire wheel too because it's the outward facing side. So now I'm going to bend out that tab. So what I'm going to do is going to be bending outward of the sign. So I'm going to flip it upside down. I'm going to clamp it to the edge of the table. You can see the table right under here. I'm going to bend it so that way it's flush with that. So I'm going to clamp it to the table in that position. Clamp it nice and tight. I'm just going to take a punch and a hammer because it doesn't really need to bend out that far. Right across the edge there. A little pop. Boom. So now they'll be able to hang the elk skull on the back. They might need to bend it down a little bit. I don't have the skull, so I really can't do that, but it should be pretty easy to bend. I'm going to leave it right there. I might take this and bend it back down. Give it a bend just like that. There you have it. One Montana Silhouette elk skull hanger. All right, thanks for watching.